Histogram. Okay. Histogram is one form of um, presentation data where we can choose to display the information of data we collect. Okay, once we have a frequency distribution or a relative frequency distribution, we can put the information in graphical form. So, histogram is information that can be placed in a graphical form, okay, by constructing a histogram. So, this is the name of a graph where we can display information in a graphical form. Okay, histogram is constructed by drawing a rectangle for each class. So I'm sure you, all of you have known what the histogram is like. Okay, we can form a histogram from Excel. The height of the rectangles are equal to the frequencies. Okay, the height of the rectangle. So a rectangle is like this. Okay, so this is the histogram. Y-axis and x-axis. So this is the histogram. The height here, the height represent the frequencies or the relative frequencies depend on which type of information that we would like to display, either frequencies or relative frequencies. And the white are equal to the class white. Okay, the white here are equal to the class white. Okay, we have learned earlier what the class white is. So axis, horizontal x-axis is a variable which boundaries a value. Okay, horizontal x-axis here is the variable, and vertical y-axis is the frequency or relative frequency. Okay, example, construct a frequency histogram and relative frequency histogram for the vehicle emissions data. So this is the histogram where y-axis represent frequency and the x-axis represent particulate emissions. I think this one from the earlier slides, we can check on the exercise 2. This one referring to the exercise 2 that we do earlier on the vehicles, emission for vehicles. Okay. And this is the histogram where the y-axis represent a relative frequency. Okay, so the data is about the same. Okay, since we use only the scale on the y-axis or unit on the y-axis is different. For relative frequency, we divide by the total frequency. Each frequency divide by total frequency. So the scalar is smaller. Okay, whereby the frequency, we get the frequency for each class. So this is histogram. Okay, this is some form of how information is displayed in histogram form. Okay, next is polygon. Okay, polygon is another form of how data is displayed to provide information for easy reading, for easy data processing. Okay, although histograms are the most commonly used graphic for representing a frequency distribution, there are others. One of these is the frequency polygon. We can also display information in the form of polygon instead of histogram. A frequency polygon is constructed by plotting a point for each class. Okay, so instead of doing the rectangle form, we construct a point for each class. Okay, the x coordinate of the point is the class midpoint. Okay, remember, x coordinate of the point is the class midpoint, and the y coordinate is the frequency. Okay, then all points are connected with straight lines. Okay, example 4, polygon. Construct a frequency polygon for the vehicle emissions data in the following frequency distributions. So earlier we collect data on the particular emissions and do the class-wide using the scale, using this class wide, and then frequency we collect which data falls into which class, and then we get the next column is the class midpoint. Class midpoints mean from 0 to 0.99 divided by 2. So in between the middle part is called the class midpoint. Same also for this one, 1.99, okay, divided by 2. Okay, 1 plus 1.99 divided by 2. So we'll get 1.495. And same goes for the rest of the class midpoint. Okay, once we get the midpoints, so all the midpoints for the class-wide, so we get the midpoint point by point. For each class-wide, we connect between one midpoint to another midpoint from the first class until the end class. So this is what we get for the polygon. So this is one of the example of the graph called polygon. Okay, next, shape of distribution. Okay, for a very large data set, okay, if we collect more and more data set, the bigger the size of data sets, the number of classes is increased and the width of classes is decreased, mean that the scale becomes smaller. Okay, the frequency polygon eventually becomes a smooth curve called frequency distribution. So we are able to get the shape of the polygon as this curve, and we call this frequency distribution curve or simply a frequency curve. Okay, you see the midpoint in between the line or at the middle of the rectangle is the midpoint. So we connect the midpoint from one midpoint to another midpoint. So we are able to get a curve. So this is called a frequency distribution curve or distribution or frequency curve. Okay, so purpose of histogram is to give a visual impression of the shape of a data set. So kalau data set yang kita dapat tu normally kita boleh tengok whether data tu is dia berlaku sangat kerap pada certain data. Macam case ni kebiasaannya untuk average akan dapat histogram yang tinggi, meaning that data yang average tu kerap berlaku, kerap appear. So kita boleh dapat shape of a data set. Okay, tujuan histogram is to give a visual impression of the shape of a data set. So statisticians have developed terminology to describe some of the commonly observed shapes. So kalau you belajar sebelum ni tentang normal distribution, binomial distribution, apa lagi? Ada lagi a few types of distribution kan. So this is based on the shape of data displayed by histogram. Okay, histogram is symmetric if its right half is a mirror image of its left half. Macam ni kan. Ini almost symmetric sebab kalau kita divide tengah-tengah tu, kita dapat on the left dengan on the right tu nak macam mirror, dia macam image. Dia hampir-hampir sama. So we call it a symmetric. Okay. Very few histograms are perfectly symmetric, but many are approximately symmetric. Selalu symmetric tu kita tak dapat betul-betul perfect symmetric, tapi almost or approximately symmetric. Okay, a histogram with a long right hand tail is said to be skewed to the right or positively skewed. Contohnya macam yang ni, kalau kita dapat bentuk histogram yang makin sebelah makin lama makin menurun, makin berkurangan dia punya frekuensi tu, ini dipanggil sebagai skewed to the right. Sebelah kanan tu dia melencong. Okay, so we call this shape as skewed to the right. Histogram with a long left hand tail is said to be skewed to the left or negatively skewed. Okay, kalau tadi skewed to the right is called also positively skewed. Kalau skewed to the left maknanya sebelah kiri tu daripada sebelah kanan dia frekuensi dia tinggi. Kemudian dia ke sebelah kiri tu dia makin berkurangan frekuensi dia. So we call this skewed to the left. Okay, or negatively skewed. Okay, satu lagi bentuk graphical representation of frequency distribution is called an ogive. Ogive is a plot of values known as cumulative frequencies. Satu ciri-ciri bagi ogive ni yang lain daripada histogram dan polygon tu adalah data display dalam bentuk cumulative yang terkumpul, frekuensi yang terkumpul. Okay, the cumulative frequency of a class is the sum of the frequencies of that class and all previous class. Ini maknanya terkumpul. Kita jumlahkan ikut turutan frekuensi sebelum dan seterusnya. Okay, an ogive is constructed by plotting a point for each class. The x coordinate of the point is the class boundaries and the y coordinate is the cumulative frequency. Ini macam mana kita nak display ogive ni dalam bentuk graph x and y. Then all points are connected with straight lines. Ini dia ciri-ciri untuk ogive. So there are two types of ogive. Ogive less than and ogive greater or more than. Okay, this is an example of ogive less than. How do we display an ogive using less than ogive? Okay, from our example total home runs earlier, so did the frequencies for the class Y, each class. Okay, the upper boundaries for each class is the midpoint between 152, the upper boundary dengan lower boundary of the next class. 152 dengan 153 ni divide by 2. So tengah-tengah dia adalah 152.5. So this is upper boundaries. Okay. And then this one 170 dengan 171 divide by 2 akan jadi upper boundaries dia adalah 170.5 dan seterusnya. So this is called upper boundaries less than. Okay, for cumulative frequency, kalau kita nak display cumulative frequency, dia start dengan 10. For the next one, 2 ni 10 plus 2, jadi 12 kat sini. So the next one akan jadi 17, which is 10 plus 2 plus 5, 7. Okay, 17 to 23 ni adalah 17 times 17, tambah ni bukan time, sorry. 17 plus 5, which is 23. Okay, and then 26 is 23 plus 3, 26. Untuk dapatkan 30 is 26 plus 4. So this is cumulative frequency. So from ogive tadi, so this is how we represent ogive using cumulative frequency. Okay. Okay, the x-axis is the upper boundaries. X-axis is the upper boundaries and y-axis is the cumulative frequency. Yang kita plot tadi from the earlier slide. Okay, from the earlier slide here, kita upper boundaries and the cumulative frequency y-axis. Upper boundaries is x-axis. So kita akan dapat graf ogive yang berbentuk begini, kita plotkan.